Backslash hashtag DogCat walkthrough. Backslash hashtag room information. Field value. Platform TryHackMe. Room DogCat. Difficulty medium. Objective: exploit local file inclusion, achieve remote code execution, escalate privileges inside a Docker container, escape the container, and obtain root on the host. Backslash hashtag step 1 enumeration. The assessment began with a full TCP port scan using Nmap to identify exposed services. The scan revealed /SSH 22, /HTTP 80. The web application was hosted on Apache and presented a simple interface allowing users to choose between viewing dog or cat images. /evidence /03 /map /full scan.png /04 homepage.png hashtag step 2 local file inclusion. Testing the view parameter revealed a local file inclusion LFI vulnerability. Directory traversal sequences allowed arbitrary files to be read from the server. Initial testing confirmed successful traversal outside the web root. /evidence /05 basic /LFI test.png hashtag step 3 source code disclosure. The application used an extension filter that prevented direct reading of PHP source files. To bypass this restriction, the PHP filter wrapper was used. The base 64 encoded output was decoded locally, revealing the application's source code and exposing how the view and ext parameters were processed. This disclosed the application's inclusion logic and suggested a path toward code execution. /evidence /06 filter bypass error.png /07 php filter base64.png /08 decoded index source.png hashtag step 4 Apache log poisoning. The Apache access log was identified as readable through the LFI vulnerability. A malicious PHP payload was injected into the user agent header using curl. When the poison log file was included through the vulnerable view parameter, the injected PHP executed on the server. This transformed the local file inclusion into remote code execution. /evidence /10 Apache access log.png /11 log poisoning curl.png /12 rce id command.png hashtag step 5 reverse shell. Using the command execution primitive, a bash reverse shell was launched to the attacking machine. A netcat listener received the incoming connection, providing interactive shell access as www data. The shell was stabilized using available Linux utilities to improve usability. /evidence /13 netcat listener ready.png /14 shell proprietary spawn.png hashtag step 6 initial enumeration. System enumeration identified that the compromise occurred inside a Docker container. Environment variables, file system layout, and mounted directories confirmed containerization. The first application flag was retrieved during this phase. /evidence /15 environment variables.png /16 find txt files.png /17 container flag.png /18 confirm container.png /19 df h.png hashtag step 7 container privilege escalation. Enumeration identified. Backup scripts. Mounted backup directory. /suid binaries. Misconfigured sudo permissions. The command allowed passwordless execution as root. This provided root privileges inside the Docker container. /evidence \20 \opt \backups \listing.png \21 \write permission /test.png \22 \backup /script /contents.png \23 /sudo /binaries.png \24 /sudo /l.png \25 root container shell.png \29 container root flag.png \step 8 Docker escape. The mounted backup directory exposed a script executed by the host system. A reverse shell payload was appended to the backup script. When the scheduled backup task executed on the host, a reverse shell connected back to the attack machine. This resulted in root access on the underlying host outside the Docker container. \evidence \26 root write test.png \27 backup tar contents.png \30 restore backup script.png \31 process enumeration.png \32 host root shell.png \step 9 host compromise. After escaping the container, the final host file system became accessible. The final flag was retrieved from the root user's home directory, confirming complete system compromise. \evidence \33 flag4.png \34 room complete.png #conclusion. DogCat demonstrates how multiple individually manageable weaknesses can be chained together into a complete compromise. The attack progressed from local file inclusion to source code disclosure, log poisoning, remote code execution, Docker privilege escalation, container escape, and ultimately full root access on the host operating system. This room highlights the importance of secure file inclusion, proper log handling, least privilege configurations, and careful isolation between containers and host systems.